Hi everyone, let's take a look at the fourth problem of blind 75, and the problem is container with most water. We are given an integer array, height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I, 0 and I, height of I. Find the two lines that together with the x-axis from the container such that the container contains most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, so let's take an example here, height. So the first line has the height is 1, second line is 8, 6, 2, 5, 4, 8, 3, 7 and so on. How can we find the maximum amount of water in the container? So ideally we have to find 2 points and see what is the area, and we have to keep track of the area in between two lines and find the one which with the maximum amount of water. Okay, so here the height is 1 1 and the answer is 1 because you can only store the area is 1 obviously. Okay, so how can we find the maximum area? Maximum area can be, for example, if you take this which is 1 and the line 7, what is the maximum area it can? So it can only contain levels from here to here. So this it is 1 and the width is going to be the index, the last index minus the first index. So that will be the value. Let's see what it is. So if it is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 0. So the area is going to be 8. Let's move to the next one. In this one, what is the area? So this is 8 and this is 7. The value is, so it can only contain up to 7. So 7 into, this is 1 and this is 7. 7 minus 1. So this is 8. 8 minus 1, 7. 7 into 7, the area is 49 and so on. So how can we solve this? Okay, let's see how yeah, so sorry, yeah, this is how we find this is how the values are. Okay, so what is the obvious solution or the brute force solution? We have to find every every point and see the area and keep the first one. So there is nothing for me to kind of write here. So ideally we will check with say I'll keep this and I'll check what is the area in this one, what is the area in this one, what is the area between this and this, what is the area in between this and this, and so on. And later I'll start with this, then this until the end of the array and so on. So we have to find every, so let's see how we can implement it. So we need a variable to store the maximum area. Maximum area is equal to, initially I'm storing it as 0. So I'll keep left and right as two variable in the loop. So it starts from, say, we can start from 0 as well. Okay, so let's len of height. Right value is in range of left plus 1 and len of height, right? Yeah. So what is the width? Width here is right minus left. What is the area? Area is going to be width and whatever is the minimum value between these two the elements are these two indices. So maximum area is going to be max of whatever we have got so far, then minimum of height of left comma height of right. So minimum of this into width of, okay. So at the end what we would get is maximum area. Let's try to run this. Okay, so yeah, this is done. What is the time complexity here? So there is two loops iterating through the list one by one, so order of n square. And what is the space complexity? We are not using any additional space except the maximum area, which is constant, so it is order of 1. Can we optimize it further? So let's see how we can optimize it. Okay. So I think I need to write, or yeah, let me reset the canvas and let's take this example. So height is equal to like this. Okay, so let me draw the, so this is 1, this is 8, so sorry for the crooked lines. 6, 2, 5, 4, 8, 3 and 7, something like this. Okay, so can be, so okay, so if you look at the existing solution, it is an order of n square. Can we make it order of n? That should be the thought in our head if when you say optimize, or are we doing any repeated work, can we avoid it? So that is how we have to think about optimization. So if you look at the loop, what defines the area? So if I take this and this particular line, which is 1 and 7, what defines, or what matters in this? So we kind of need the minimum element, right, and the width, right? That's all we need. So something that we need to note is, farther the line, the more will be the area, right? So instead of doing it twice, can we use it like for example with 2 pointers? So one will stay here and one will stay here. So we have to keep the minimum from the right, minimum from the left as well when we traverse, and we keep it in a loop and keep updating it and iterate until like each of these 2 pointers meet. Okay, so what is the benefit of doing this? We can do it in a single pass, right? So how can we do it? Let's see how we can do this 2 pointer method. So maximum area still remains the same. We are going to store the answer here. So I'm going to start, left is 0. What would be right? What would the right would be length of height minus 1. That will be the value. So we have to keep shrinking towards each other until we find the maximum area. So we can do it in a single loop. So what would be the width? Width would be right minus left, right? And what is the maximum area? It's a similar way. Maximum area would be max of the existing value, max area, and minimum of height of left, comma height of right, and into width. So this is similar way we found the max area earlier, but only with in a single pass. How do we shrink it, or how do we move the left or right? So if height of left is less than or equal to height of right. So if you look at this particular point and this, moving to the right would give us more area, more volume, right? So what we do is, if the left is less than or equal to the right, we increase the left. In the other case, if suppose this case, like we are at 8 and on the right it is 3, how can we obtain more volume? So we have to move like inside, because we have already computed the maximum area. Now we have to move to the left. So else case would be height equal to 1. Then we can return maximum area. Yeah, so we got it. What is the space complexity here? So we are just using a couple of variables, so it's constant, and the time complexity is order of n. So let's try to submit and see if it runs or if there is any edge case. Okay, success. So yeah, that's the end of the problem container with most water, which is the fifth problem that we started. I'll be back with the next problem soon. Until then, see you and thanks for watching. Bye bye.